Okay, good evening everyone. I'm very sorry for 5 minute delay. There was some technical glitch in MS Teams, so my camera was not ready. So I had to restart my computer. So I'm very sorry for delay. Okay, so let's start. Good evening everyone. I welcome you all for the live session number 9 for the course content week 9. The course is non-conventional energy resources, and the course instructor is Professor Pratap Haridos, sir, from IIT Madras, and I am his TA for this course, Amit Kumar Sharma. So today, as usual, we will cover the week 9 course content. Briefly, we will revise the course content of week 9, and after that, we will solve some sample assignment questions. And based on those assignment questions, you can do your current assignment question, and maybe the things will be more clear to you. Okay, so let's start with the week 9 course. The first is ocean thermal energy conversion, OTEC. So as in previous classes, we have covered the solar energy, we have covered the wind energy. Okay, we are covering the renewable energy sources. Now we are covering some other renewable energy sources that are also in use. Okay, if anyone having any issue regarding the internet, na, please tell me, because today I'm due to weather, I'm facing some technical issue in my internet also. So if my video and my audio or my PPT is not clear, please let me know. Okay. Okay. So the basic principle of OTC is the temperature difference. So the temperature difference between the warm water at the surface and the colder water approximately 1 kilometer below the surface is used to run a heat engine, and energy is extracted from the same. So if we see suppose this is the ocean, this is a water surface. So the water surface is having solar radiation. Okay. So due to the solar radiation, the surface temperature of the water for the ocean or for the sea is high as compared to the water just below approximately 1 kilometer to 1.5 kilometer. So there will be a temperature difference, and this temperature difference can be of the order of 15 degree to 25 degree centigrade. So you can see there is a huge temperature difference, 15 degree, 25 degree centigrade, because we know that the upper layer is directly exposed to the sun rays. Okay. So below this, the upper layer of water will conduct some heat to the lower layer, and in similar way, by layer, by conduction and convection, the heat will be transferred to the other layers of water. Okay. So as we go deeper, the temperature will be lower as compared to the surface temperature. So the temperature difference is of the order of 15 degree centigrade to 25 degree centigrade. Okay. So you can see we are having a temperature difference. So by using this temperature difference, we can develop a system so that can generate energy. Okay. Because we know in heat engines we are having two sources, we are having two sources at different temperature, and due to the temperature difference we can run the heat engine. By similar way, we are having temperature difference, so the temperature difference is there. So by using the temperature difference, we can develop a system that can generate the electricity. So let's see how it works. So the thermal profile of seawater is the first 20 meter absorbs sunlight. So first 20 meter of the surface absorbs sunlight. Surface freezing at poles to 36 degree in the Persian Gulf. Now the water is turbulent and mixed for a few hundred meters. So up to some 100 meters, water is turbulent and mixed for a few hundred meters. Boundary of a few hundred meters between mixed layer and undisturbed water below called thermocline. Okay, so boundary of few hundred meters between mixed layer and undisturbed water below is called thermoline. 90% of sea water below thermoline temperature around 3 degree. So up to this thermoline, where the turbulent mixing of water is there, so the upper layers of water, those who have absorbed the sunlight, so they will maintain some temperature, okay. But below this thermoline, the temperature will be around 3 degree, okay. And 90% of water is below this thermoline. Only 10% of water is above thermoline. So we are also having some challenges working under sea, because as we go deeper, the pressure will be increased very high. Okay, so marine trench is only 11 kilometer deep and visited by 3 people only, and the moon nearly 3,84,400 kilometer and visited by 12 people. So you can see the difference. The marine trench is only 11 kilometer deep, but as of now only 3 people have visited. But the moon is so far, very very far, but visited by 12 people. Okay, and we are sending more moon mission or Mars mission also. Okay, all over the world they are trying. Okay, majorly America, India, Europe, France, these are trying. Okay, so basically this show that working under sea is more difficult than going to space, because in space uh, the pressure is not an issue because there is vacuum. Okay, so pressure is not an issue, but as we go deeper in the sea, the pressure increase very high. Okay, so we can so the pressure is very high, so it will be difficult to work under the sea. So this is a simple, you can see a diagram. Okay, this is the surface of sea. This is a point at 1 kilometer distance. Okay, so here we can assume that at the upper part, suppose temperature is 35 degree. Okay, and the lower part temperature is around 15 to 20 degrees centigrade. Okay, so there is basically a temperature difference of 15 to 25 degrees centigrade. Temperature difference is there. So by using this temperature difference, we can develop a system. Okay, so the system will supply the hot water and cold water, and using the temperature difference we can generate the electricity. We can desalinate water, because the sea water is having huge amount of salt content. So we can, using this system, we can desalinate the water, and it can be used for drinking water and for irrigation. And we are having the cold water maybe around 10 degree also, maybe 5 degree or lower. Okay, depending on the location. So we can use the cold water directly for mariculture and air conditioning. So these are some important purpose, that by using this temperature difference we can generate electricity, we can use it for drinking water and irrigation, we can use for mariculture and air conditioning. Is anyone having any issue? Please let me know. Is anyone online?
Yes, no issue. Go ahead.
Okay, thank you. Today actually weather is not good, so there is some issue in internet connectivity. If you face any issue, please let me know.
Yes, initially it was not connected, but
okay, so
got it connected. Yeah.
Okay, thank you. So this diagram you can easily see that we are having a vaporizer and a condenser. Okay, So actually this is a closed system. Yeah, the working fluid is ammonia. We are using a working fluid ammonia. Okay. So this ammonia will take heat and it will vaporize and it will release heat and it will again condense. Okay. So in this way, a phase changing of ammonia is occurring, and using by the phase changing, when the ammonia is in vapor form, we are running the turbine. Okay, and turbine is generating the electric power. So you can see the suppose surface water is around 15 degrees centigrade. So here the surface water is coming 15 degree and is coming out at 10 degree, and we are supplying the cold water that is below 1 kilometer in the condenser. Okay, so it is at the surface, and this water is at the depth of 1000 meter, or you can say depth of 1 kilometer. Okay, so this water is depth of 1 kilometer, cold water at 5 degree, surface water 15 degree. So this 15 degree gives the heat to the ammonia, and we are using a pump. So this pump is pumping the ammonia. Ammonia will go through these pipes, and there will be heat exchange will occur in the ammonia and the water. Okay, so ammonia will gain some heat and convert to the vapor, and this water will give heat to the ammonia, and the temperature will decrease. Okay, so the water will coming out at 10 degrees centigrade. So now the ammonia will go run the turbine, and after turbine again it come to the condenser. Okay, where the cold water is flowing. Okay, so it will give, now the ammonia will take some heat and again convert it into liquid. Okay, so in this way we can tap off the we can use the temperature difference of ocean water to generate the electricity to run the turbine. Okay, so there are possibility of open cycle and closed cycle in our previous diagram with the psi and closed cycle. So in case of open cycle, warm seawater evaporates at low pressure. So we will develop some low pressure, so it will evaporate at low pressure. It runs turbine, it condenses by the cold seawater. Okay, and it runs turbine, then it can generate electricity. Okay, when the water condense, okay, so the condensed water will be desalinated water. Okay, so we can use it for drinking purpose, we can use it for irrigation. Okay, so in this way there are multiple use of this system. So for closed cycle, low boiling point liquid, we use low boiling points liquid like ammonia. Its boiling point is minus 33 degree, so it can be used in between the temperature range of 10 to 30 degrees centigrade. Okay, so because its boiling point is very low, warm water makes it evaporate. The warm water makes it evaporate and run turbine. Cold water condense it afterwards. Okay, so we have seen warm water is evaporating it, and the cold water is again condensing it. So we can use the open cycle and closed cycle. So the conclusion from this is the OTS is available to tap in almost all coastal regions. Okay, so the OTS is available to tap in almost all coastal regions. It can be set up off shore as well, offshore as well. We can set up offshore as well. Efficiencies are low because the temperature difference is very less, so efficiencies are low. Stability of structures in the presence of water currents is a factor to address. So when water currents are there, so there will be high pressure or impact of water waves also. So the stability of structure is difficult to maintain. So whenever we are designing this type of structure, we have to consider these factors. Okay, and we have to give more concern to these. Okay. My pointer is visible.
Yes,
Hello.
yes, visible.
Anyone? My pointer, my
Visible.
pen is okay. 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 Thank
Yeah.
you.
Yeah.
Okay. Now come to the geothermal energy. So this diagram diagram is showing a cross section of the earth. Okay, so this is a cross section of earth. So we are having multiple layers. The first one is crust, then upper mantle, lower mantle, outer core, and the inner core. So we are having these layers. Okay, so the crust is having thickness up to 30 kilometer. Upper mantle is 720 kilometer, lower mantle 2170 kilometer, outer core is 2260 kilometer, and inner core is 1220 kilometers. So you can see the thickness in kilometers very, very high. Okay. Core is made of iron, nickel, noble metals, and the metal is sulfide and oxide rich. Okay. And the crust is oxides. So these are the composition of Earth. So the crust is 30 kilometer. Okay. So let's see and what are the other parameters, because the thickness is, you can see the very high in kilometer range. So we can say the temperature will also vary accordingly. Let's see. So the depth, okay, we have covered this. So the, if we know the depth, suppose this was the thickness of each layer. Okay, crust, upper mantle, lower mantle, outer core. Now what is the depth from the surface of the earth? So for crust is up to 30 kilometer, upper mantle 750 kilometer, lower mantle 2920 kilometer, outer core 580 kilometer, and inner core is 640 kilometer. So from, if you are going from surface to the center, then you are having 6400 kilometers. So this is the radius of the earth. Okay, so the radius of the earth is 6400 kilometers. So the temperature is also vary according to layers. In the crust, the temperature vary from 0 degree to 700 degree centigrade, upper mantle up to 1000 degree, lower mantle 3500 degree centigrade, outer core 4000 degree centigrade, and inner core is 7000 degree centigrade. So you can see the temperature variation is huge. Okay, so as we were using the temperature variation of the sea, similarly we can use here also. Let's see what are the possible techniques, or what are the possible ways by which we can use this temperature difference, and we can run the turbine to generate the electricity. Okay, so the deepest spot in the ocean is the Challenger Deep or Mariana Trench. Okay, in the Pacific Ocean near Japan, it's 11 kilometer deep, deeper than the height of Mount Everest. Mount Everest is 8.9 kilometer, but it is deeper than the Mount Everest. Now the deepest
Sharma
spot
sir,
in the land.
excuse
So
me,
drill
Sharma
hole
sir.
in Soviet pen. Yeah, hello. Yes, yes.
Yeah, Sharma sir, I just wanted to know for the OTAC, what are the challenges associated with it?
Okay. For the OTEC.
Yes,
Yeah.
because OTAC is like efficiency is so low, and then it doesn't have any pressurizing chamber or something.
The
Efficiency
major
is
the
as per the theoretical
major
efficiency is
challenge is to
6%.
set up the structure. Yeah, yeah. So the major challenge is the setup of the structure in the sea. That is a major challenge.
Mm.
And after that, the suppose transmission of that electricity, because you are generating heat in somewhere in the ocean, and
Mm.
then you are transferring that energy to somewhere else, because in ocean, near
Mm.
ocean, we are not nobody is living near that area. So you have
Mm.
to transmit that energy. So that will also increase the cost. So if you're generating suppose energy, but you have to give more energy in the transmission, because there will be also transmission losses also. So
Yeah.
in that way, if you think, then it's very difficult to. Okay. So these are the major challenges.
And so it depends.
Your sound is not coming. Please
Is it
repeat.
dependent on is it dependent on ocean currents?
Yeah, ocean current. Actually, we are just ocean current. You can say that will vary the upper layer, the surface temperature. So yeah, it depends. It will be good if we are set up in the, you can say, the like where the water level like remain at the same temperature. If you are like, if the more ocean current is there, then there will be more heat transfer at the upper side at the upper surface layers. Okay, so maybe the temperature variation will be maybe 1 or 2 degree lower. Okay, suppose if you are using the 1 kilometer below temperature range, and if you are having
Yeah.
more ocean currents, then more turbulence will be there. So that will affect the temperature difference gap. Okay, so maybe you need to go more lower than area. So it will affect, actually. It will also affect the stability of structure also.
But turbulence are limited, sir, at a certain what do you call ISO line.
Yeah, turbulence are limited, but suppose if more turbulence is coming, then the temperature will be different, na? Suppose
Difference will be there.
there are two water. Suppose there are two vessels. Okay, one vessel is containing still water, and one vessel is containing the turbulent water. Complete turbulence is there. Okay, so the both vessels are getting the solar radiation. Okay, so
Okay.
if you compare the surface temperature for this vessel number one as compared to vessel number two, so what do you think?
Vessel number 1 is at high temperature.
Yeah, so the surface temperature of vessel number one will be higher as compared to the vessel number two, because vessel number two is having more turbulent flow, so the heat will dissipate to the lower layers. Okay, heat will dissipate to the lower layers, but in this, it's no as compared to number two, there is no turbulence, so heat will not dissipate. Okay, so there will be more temperature difference. Suppose we are getting 15 degree of temperature difference in like 1 kilometer. Okay, but in this vessel number two, for 15-degree temperature difference, maybe we have to go 1.5 kilometer. Okay, so it means that your equipment should be more exposed to the pressure, because every meter is very critical for the equipments. Okay, so we will try to get the maximum temperature difference within minimum distance. Okay, minimum depth. With the minimum depth, we want to get maximum temperature difference. Okay, so this is the reason. These are the challenges associated with the OTEC.
OTAC is difficult.
Yeah, it's quite difficult, but it can be useful for, suppose some today we are using like refineries set up
So
in the ocean.
currently,
So
so
for
currently any plant is there which is working on OTAC in India or outside?
plants are there, but we have to search, actually. I'm not remembering the exact locations or name, but plants are there. Yeah,
Okay.
you can search after the class. Yeah, sure.
Okay. Thank you.
Okay, welcome. So the deepest spot in the land is drill hole in a Soviet peninsula of Kola. So it is 12 kilometer deep. Okay, so now compare this 12 kilometer to the thickness of the earth. Okay, so you can see the crust layer itself is 30 kilometers. Okay, and there are 5 layers, and we are having depth up to 6,400 kilometer. Okay, and as of now we have only just gone up to 12 kilometer. Okay, so it's very less. 12 kilometer is it's very difficult to drill up to a certain depth. So as of now we are only in the crust section. Okay, so let's see what are the parameters at this. So as we know, there are different layers, so we can find the composition of earth can determine from there. Some methods are there. So the first is the flow of heat from inside the earth. Okay, using some instruments we can get the flow of heat from inside the earth, and we can determine the composition of the earth layers. Experiments on surface minerals and rocks under high pressure and temperature, gravity and magnetic fields of earth, and the path of earthquakes waves traveling through the earth. So using these four methods, we can measure the composition of the earth. Okay. For more detail, you can refer the class videos, and maybe you can refer some reference books. So basically, these are the four methods. Okay. So the principle of geothermal energy use. Now for geothermal energy use, what is the basic principle? The basic principle is that temperature gradient is of the order of 25 degree to 30 degree per kilometer. So per kilometer depth, we are having 25 to 30 degree of temperature difference. Okay. So we can use this temperature gradient to run a turbine and to generate electricity. Now the 20 degree per kilometer in northern latitudes and 40 degree per kilometer closer to the equator. Okay. So if you are going towards the equator, then the temperature difference is 40 degree and northern latitudes 20 degree. Okay. Average on average you can say the 25 to 30 degree per kilometer temperature gradient is we can get through the geothermal energy use. Okay. So the principle of again the temperature gradient is of the order of 25 to 30 degrees centigrade. Common use is 150 meter to 200 degree. Okay. So we are using up to 150 to 200 meter with temperature difference of temperature increase of less than 10 degree. Oil industry drills 5,000 to 10,000 meter temperature greater than 350 degree. Okay. So oil industries they are going up to 5 kilometer to 10 kilometer, and they are getting the temperature more than 350 degree. Okay. So they are getting the huge temperature, but the electronics will struggle. But the electronics are struggling at this depth. Okay. So faults will enable access to high temperature. So there are some faults on the land on some area. So that will enable access to the higher temperature. Okay, we can access from the faults, some cracks on the land. Okay, so from that we can get the temperature difference easily. So some these are the some two locations. Okay, so deep water horizon. Okay, it's 10.5 kilometer deep, and it's Sakhalin 1, Russia is 12.3 kilometer deep.
Sir,
So for
excuse me.
any system,
Excuse me.
yeah.
Excuse me. These faults are created because of the terrain of the earth, or how is it like this? What is the reason for these faults? Fault of on the earth surface, or like how is it?
Yeah, they are just you can say maybe I'm not know the exact answer, but maybe due to the tectonics plate activities, maybe the during earthquake and due to the tectonic activities of the plates of the earth, they are created. Maybe I'm wrong. I don't know actually.
Hmm. This
We have to check actually.
these faults are used basically in some of the regions to create get a better difference of temperature and higher temperature. But the reason
Yeah,
for
because
these
from these
faults,
cracks we are getting steam. We are getting directly actually high temperature steam directly
yeah.
from these cracks somewhere. Yeah.
Ah,
So we
okay.
can use the temperature difference easily.
Like
Yeah.
spring, you call it as a hot spring or something?
Just give me just 1 minute. Just so I'm very sorry. Just 1 minute. Hello.
Yes.
Hello. Yeah.
Yes.
Pardon.
Just wanted to clarify the reason for to how to locate or how the faults are created or how they are located.
Actually, I'm not the expert in these area. So
Anyway, it is
you
just
can actually refer
a
some reference book. Yeah.
yes, some yeah, okay. Anyway,
Yeah. This.
thank you.
Yeah. if we guess from like basic science, then maybe due to maybe the earthquakes and plate tectonics, those activities are creating these cracks.
Because the word fault, what I understand is a fault is a electrical word where there is a short circuit or something.
No,
But
no, no, no.
this
It's cracks. It's cracks actually. Cracks. Faults, you mean to say the cracks? Okay. So suppose there is a land area. So that land area is having a deep crack. So maybe that crack is going up to 1 kilometer, 2 kilometer, 3 kilometer. So that crack is automatically generated. Okay, up to suppose 3 or 5 kilometer distance. At no, there will be groundwater, and temperature difference is there. So that groundwater is automatically converted into steam, and that is coming out from these cracks.
Okay.
So these are the faults actually.
Fine.
Okay.
Thank you.
Large cracks on the earth surface. Okay. So from these cracks we can access up to 3 to 4 kilometer, maybe it depends on the location. So we can directly getting the steam from those points, from those cracks, because groundwater is flowing. There is temperature difference. So due to that, the groundwater is converted into the steam and coming out. So we can put some pipes, put some setups, and we can use that steam to run the turbine. Okay. So whenever we are installing any geothermal energy systems, so we are getting like approximately lifetime of 30 years. We are assuming that that particular like the particular hole we have created, or the particular crack we have developed or anything, so that will give up to 30 years. Okay, that can be run up to 30 years. So now the geothermal power plants use steam to produce electricity. So basically we are using steam to produce electricity. Okay, now there are different ways that we can tap off this. So let's see. The steam comes from the reservoir of hot water found a few miles or more below the earth's surface. So there are reservoirs of hot water. Okay, so when we go few miles or more below the earth's surface, we will get hot reservoirs. Those are giving the steam. Okay, so that steam can rotate a turbine that activates a generator. So turbine, the shaft can be connected to generator, and we can get electricity. So there are three types of geothermal power plants. Normally, three types of geothermal power plants are there. The first one is dry steam, second is flash steam, and third is binary cycle. Okay, so these are important actually. Dry steam, flash steam, and binary cycle. Now let's see what is the difference. So the first one is dry steam. So dry steam power plants draw from underground resource of steam. So dry steam, basically dry steam, as the name suggests, you are getting the dry steam directly. Okay, you are getting the superheated steam directly from the resources, and you are running the turbine from that steam. The steam is piped directly from the underground wells to the power plant, where it is directed into the turbine or generator unit. There are only two known underground resources of steam in the United States. So for the United States, these are the two resources are there. They are producing the dry steam directly. The geysers in Northern California and the Yellowstone National Park in Wyoming, where there's a well-known geyser called Old Faithful. So these are two locations. For more detail, you can search it, or you can refer some other book. Okay. Since Yellowstone is protected from development, the only dry steam plant in the country are at the geysers. So maybe Yellowstone National Park is under protection, so there is no activities going on. Only the dry steam plants are in the country, in the US, is at the geysers. Okay. So basically in dry steam we are getting the superheated steam directly, and we are running the turbines directly from that steam. Now second one is flash steam. So in flash steam power plants, these are most common and use geothermal reservoirs of water with temperature greater than 182 degree. Okay. So mostly we are using these types of power plants, flash steam, temperature greater than 182 degree. This very hot water flows up through wells in the groundwater under its own pressure. as it flow upward, the pressure decreases and some of the hot water boils into steam. Okay, as we know that if we decrease the pressure, the boiling point become lower. Okay, so at low pressure, water boils less than at 100 degree. Okay, so the steam is then separated from the water and used to power turbine generator. And any leftover water and condensed steam are injected back into the reservoir, making this suitable resources. So using the flash steam, okay, it's having temperature up some part of steam and some part of water. Okay, so we decrease the pressure, so some more part of water converted into the steam, and we can use the steam into turbine, and we can flow back the hot water into the, again you can say, the reservoir. Okay, this is the flash steam. Basically we are using some flash chambers. Okay, so flash chambers basically decrease the pressure and try to maximize the steam from the hot water. Okay, the third one is binary system. So binary cycle power plants operate on water at low temperatures. So in binary cycle, the temperature is low, in the range of 107 to 182 degrees centigrade. Okay, so binary cycle plants use the heat from the hot water to boil a working fluid. So they use heat from the hot water and they boil a working fluid, usually an organic compound with a low boiling point. So again, like as in OTEC, here also we are using a low boiling point fluid that can be used in the turbine. Okay, so the working fluid is vaporized in a heat exchanger and used to turn a turbine. The water is then injected back into the ground to be reheated. The water and the working fluid are kept separated. The water and the working fluid are kept separated during the whole process, so there are little or no air emissions. Okay, so these are both separated. So these are the binary system. So basically, three types of system we have covered: dry, flash, and binary. So this is the example of superheated system. It's rare to find. Actually, it's difficult to find. Only maybe one or two systems are all over the world. Maybe for the more detail, you can check. So direct, you can see the production well. The steam is coming directly. It's running the turbine. Okay. After the at the outlet, it's going back to the injection well. It's generating the electricity. Okay. And this one is the saturated steam. So like you can say the flash one. We are using a flash tank or flash chamber. So this flash chamber will increase the amount of steam. Okay, and run the turbine. Okay, cannot be used directly since it can damage the turbines. Okay, we cannot use directly because the production well is producing the water plus steam. Okay, not directly steam. Water is also there. So these water particles will damage the turbine blades, and turbine blades are very costly. Okay, so these water particles can damage the turbine blades. Okay, so we cannot use this directly. We have to convert into complete steam, then only we can use hot water. So in, like you can say, the binary fluid, we are using butane, isobutane, or pentane. So this is a fluid we can use. So you can see the production well, the water flow in the heat exchanger. In heat exchanger, from this green you can say the binary fluid is there. So this binary fluid will work as in a closed cycle. Okay, exchanging the heat in heat exchanger with hot water. In this way we can run the turbine and generate electricity. So these are the fluid, butane, isobutane, pentane. So the conclusion is geothermal energy is available with differing levels of heat. So geothermal energy is available with differing levels of heat. We are getting superheated, saturated, hot water. Okay, geothermal plants have to be designed to account for the different prevalent conditions. So we have to design according to the condition we are having. Now come to the biomass. Now biomass energy. So power companies are under pressure to find alternatives to fossil fuel such as coal. As currently we know the most of the power plants are using coal-based power plant, coal thermal plant. So they are using coal. Okay, and coal is fossil fuel. Okay,
So,
due to
Sharma
coal we
sir,
are getting the yeah, please.
sir, I have one question. Actually,
Yeah,
that
yeah.
was actually when I was also seeing the slide. That there is a superheated steam
Okay.
which is being used, which is at very high temperature. Now, the superheated steam
Yeah, right. Yeah.
also has got water droplets.
No. If steam is superheated, then it will not have water droplets.
But there is how what is the difference between saturated steam and superheated steam?
I think you have seen this diagram. Okay.
No, I'm not seeing any diagram. I am just getting some question out of my mind. That super
No,
saturated
no,
steam.
no, no, no. I drawn a diagram. Can you see the diagram?
Yes.
So this is the, you can say, the diagram for water. Okay.
Oh,
PV
steam.
diagram. Okay. So yeah,
Okay,
water
PV
for
diagram.
water. Okay. This range is saturated. This is saturation. This is superheated, and this is subcooling. You can say in liquid region. Okay.
Liquid.
So there
Okay.
is certain pressure and temperature condition. Okay.
Mhm.
So after, you can say, you can see this in between the diagram. Okay. This area.
Mm.
This area is saturated. It means the water and the steam. Okay. They are at a conditions that they can easily convert into water, or water can convert into steam. They are
Sure.
not fully saturated. If they are fully saturated, then they come at this point, location A. So the
Okay.
vapor fraction will become
Higher.
1.
One. Sure.
And at this point, location B, X is 0, vapor fraction is 0. So it means completely liquid. Okay, at location A, it is X equal to 1, means completely vapor. There is no water droplets. If in between the A or B, maybe point C is there. So X is suppose 40. Okay, 0.4 you can say. So it means that 40% is vapor and 60% is water. Okay.
Sure.
So basically the pressure is same. This pressure is same depending on the temperature. Okay.
Mm.
So these are the isobaric line. You can see the binary. You can see the this diagram for the water. Okay, PT diagrams, PV diagrams for the water. For saturation condition, you can refer for more details for any thermodynamic book. Okay,
Sure.
so
See.
if you are in superheated region,
Mm.
so it means that you have crossed the X equal to 1. So there will be no water vapor for sure. If you are in saturated condition, then there will be water vapor maybe. Okay, because
The steam. Okay.
those, yeah, those conditions are having some, you can say, the balance. Okay, they are having this, they can easily convert into the water or vapor also, both. Okay, so depending on the pressure and temperature, there will be fraction of steam. Okay,
Okay.
yeah, so superheated will not have any water droplets.
So you will put a flash chamber to avoid the conversion.
Actually, flash chamber, we are using the flash chamber. Flash chamber is a device which decrease the pressure. Okay, you are having, suppose you are having hot water with X equals to 0.7. Okay, so suppose 70% is your steam vapor and 30% is very hot water. Okay,
30%.
so if we will decrease the pressure, so pressure will decrease, it means the boiling point will decrease. So maybe more 10% will convert it into steam. Now you will get x equal to 0.8 maybe. So more water will be converted to steam, because suppose earlier pressure was suppose 1 bar, but flash chamber, so 1 bar 100 degree is the boiling point. Okay, so water will convert into steam at 100 degree centigrade. But if you decrease the pressure, maybe you decrease the pressure in flash chamber up to 0.7 bar. Maybe now you require only 60 degree centigrade water. Okay, so the water which is at 60 degree centigrade now converted into steam. Now the water which is at 80 degree again convert to steam, 90 degree converted to steam. Okay, so it means that from 60 to 100 degree centigrade water range, now we are having steam. Earlier it was in water phase, okay, but now we are having in vapor phase. Okay, I think your doubt is clear now.
So it means like flash chamber is for control for converting the content of
Water into steam.
Water into the steam.
Yeah. Place, you can see the place chamber mean it's like converting the water by decreasing the pressure to steam. Okay, it decrease the pressure and convert the water into steam. Okay.
Thank you.
Okay, now come to the biomass energy. We have covered the geothermal, ocean. Now we are coming to the biomass energy. So the biomass, the power companies are under pressure to find alternatives to fossil fuel like coal, because most of the power plant are using coal-based power plant. They are using coal for the generation of electricity. Okay, so percentage of renewables in energy target is European Union is at 20% by 2020. India is having 40% by 2030, and US states taking initiative likely 20% by 2020. So due to the issues of global warming, okay, every country or every unions are setting some targets by which they will increase the percentage of renewable energy in the complete energy market. Okay, suppose if our 100% energy is coming from fossils as of now, so they are trying to use 20% there by the renewables, so the fossil will get only 80%. They're trying to reduce the percentage of fossils by increasing the percentage of renewables. Okay, so in which EU is having 20% by 2020 target, India is having 40% by 2030. So what is biomass? So biomass, as we can say, the bio, it means from nature. Okay, so fuel derived from the plant matter, that is under biomass. It is considered as clean and renewable. So it actually issue of debate clean and renewable. Clean, maybe we will see in for the slide how it can be clean. Renewables mean it can easily replenish. Okay, because trees are growing. Okay, again some crop is growing again and again. Okay, so in that way the biomass is renewable. So versatility is it solid, liquid or gas. Okay, already supplies about 10% of the world energy demand. Currently biomass is supplied in 10% of farming process involved. So the biomass energy having small scale wood gathering, like in small villages or small areas, they are collecting the wood and using some conventional cook stoves. Okay, by burning the wood to generate the heat or for cooking purpose. And from large scale farming process, some farming is also involved today, because we are having various process by which from agri residue we can generate biogas, we can generate you can say the ethanols, and we can blend those into the we can actually we can generate the biofuels also. Okay, so we can add those fuel in our energy mix. So these are having significant source of employment, because every country is setting some targets for the companies. Okay, and companies have to fulfill those targets, because suppose energy companies. So today maybe you have heard about the green credit actually. So carbon credit and green credit we can say. So every company uh, have to follow the carbon credit scheme. Okay, under that scheme I think they have to show that we have like uh, we have saved this much of carbon per year as our previous process. Suppose some company is using previously for coal for the energy purpose. Now they have reduced the coal, and and the instead of coal now they are using biogas for the energy. Okay, so if they are decreasing the coal, it means they are decreasing the CO2 emission from that part. Okay, in that way per years energy emission will be counted, and based on that they will given some carbon credits. Okay, that they have saved this much amount of carbon from emitting in the atmosphere. So based on that they will be given some rewards in the form of carbon credits, so that are very useful. So in this way more companies will try to move towards the biomass energy. So this will generate significant employment. So let's see how we can generate. So biomass agriculture is also very important. Farmers grow corn for producing ethanol. So farmers are growing corn for producing ethanol. Okay, because they are growing, because corn is a by using some process we can generate the ethanol from the corn. So farmers are growing corn not for the food supply but for the ethanol production, because they are getting maybe more price when they are selling to the companies. Those are generating the ethanol. So it's an alternate source of income. Competition with food resources. So there is a competition with food resources, and we are having an alternate source of income. Okay, suppose if they are selling the corn as a food resource, then maybe they are getting suppose 2 rupees per kg. But maybe ethanol is more demanding, and ethanol can be mixed with the petrol diesel. Okay, so maybe that will give them 2.5 rupees per kg. So that's why they are getting more incentives in the corn for producing ethanol. So they will sell to the this area only, or maybe they can grow more because the food demand may be limited. So they can sell the excess quantity for the energy companies. In this way they are having an alternate source of income also, and they are having competition with the food resources. Bio waste we can use. Straws, like biomass is often byproduct or waste product from agriculture. So biomass is a byproduct or waste product. Okay, so whenever a crop we are cultivating, then the remaining part is biomass. So that biomass can be used for various purposes like biogas, biofuels, and etc. Like straw is a major byproduct from grain production, like 40% by weight of overall product. So straw is a major byproduct, like 40% is by weight. So you are having suppose 1 kg of grain production, then you are getting 400 gram of straw. So billions of tons produced globally. So straw is producing billions of tons. Only 100 million tons used, rest burnt in the open or allowed to rot. So you can see the numbers. We are generating billions of tons of straw globally, but only 100 million tons is used for the energy production. and rest is burnt in open. That is again a huge issue for the global warming and climate change. And rest is allowed to rot. So basically, we are not using the potential of that straw. Okay. And as you are aware, as in Delhi, due to the burning of the straw from Haryana and Punjab side areas, so the AQI of Delhi is for particular months very severe. Okay, more than 300 to 500 sometimes. So it's very severe. Okay, AQI due to this burning of the crop, burning of the straw. So crop residue burning in October to November and pollution in Delhi. So from October to November, the crop burning is the major concern of pollution in Delhi, major reason of pollution in Delhi. So what are the substitutions? So what are the substitution? Like for coal, suppose we are using coal for generate heat, and that heat can be used to generate steam. So instead of coal, we can directly combustion of wood. So we can directly use wood instead of coal. Now coal, or we can use the charcoal. Wood heated in the absence of air. We can use charcoal also. Removes volatiles twice the energy content per unit mass. So charcoal is having twice the energy content from the wood. Petrol, instead of petrol, we can use ethanol. Ethanol can be generated by the fermentation of corn or sugarcane in anaerobic conditions without air conditions. Okay. Diesel, instead of diesel, we can use biodiesels. So biodiesels can be generated from vegetable oils such as soybean oil. Natural gas, CH4. Instead of CH4, we can generate biogas from organic waste using anaerobic condition. Today, I think all of you aware, government of India is so much focusing on biogas. Okay, we are having a sort of scheme. So under this scheme, all over the India, 5,000 biogas plants are promised, and maybe more than 50 or 45 have already started, and I think 3,000 is underway, or letter of intent have already issued. So from these plants, they are using the large amount of agri residue, large amount of biowaste from food industries. Okay, food processing industry they are using, and they are generating the biogas. And biogas, maybe you are all aware, is combination of CH4 plus CO2 majorly. Okay, CH4 in the range of 40 to 60%, and CO2 in the range of 40%, 40 to 45%. Okay, so in this range, they are upgrading this biogas. So basically, moving next to CBG. Compressed biogas. So this compressed biogas is equivalent to CH4 or natural gas. Natural gas, because now this CBG is having more than 95% of CH4. So this CBG can be directly used in the CNG vehicles. Okay, so we are replacing the natural gas. Currently, as of now, India is importing around 50% of the natural gas. Okay, so we are trying to remove, we are trying to decrease the import. We are trying to half this number actually. We're trying to come to the import to the 6% only. We are trying to reducing the import by increasing the CBG in supply chain. Okay. So top 10 nations in biomass electricity gigawatt are. So these are top 10 nations. Those are generating the electricity using biomass. So first is the US. Second is China, Germany, Brazil, UK, India, Italy, Sweden, Finland, and Austria. So in this way, you can see India is at the number 6. Okay. So we are increasing rapidly actually. Now we are focusing more toward the biomass energy. So maybe after 4 to 5 years, our ranking will improve. Okay. So as per the MNRE data, these are the top 10 states in biomass capacity. Maharashtra, 100, 1112 megawatt of biomass capacity, electric capacity. UP 937 megawatt, Karnataka 737, Tamil Nadu, Andhra Pradesh, Telangana, Chhattisgarh, Punjab, Rajasthan, Gujarat, and all. So these are the pie chart that is showing the top 10 states in biomass capacity. So 32% of energy in country from biomass. As of now, we are having 32% of energy from biomass. So it impacts 70% of population. Okay, so biomass is having impact on 70% of population. So you can see the importance. 5,940 megawatt biomass based power plants we are currently having. 4,946 megawatt grid connected and 9,994 megawatt of grid power plants. So these are the data by the MNRE. Bagasse is also a major part of the above. So actually bagasse is a major part in these biomass based power plants. Okay, what is a bagasse? Bagasse is a fibrous remain after juice extracted from sugarcane. So from sugarcane industry we are getting it. So bagasse is a fibrous remains after juice extracted from the sugarcane. Okay, so we can generate biogas from this. We can generate biodiesel also, biofuels also. Okay, so it's playing a major role in the biomass based power generation. Now come to the point, is biomass is clean. So carbon released is what was captured by the plant originally. That's why we are saying it is clean. Okay, because you are releasing the carbon, because if you are burning the biogas, then still you are releasing the CO2. Okay, if you are burning the wood, then again you are releasing the CO2 and other components also. So carbon is released, but we are thinking that we are again capturing by the plants. Okay, but time scale is very important, and some other impurities also there. Impact on wildlife. So if we are cutting more trees, then it will also impact on wildlife. So time scale, you can see the lifespan of a tree is 50 years to 3,500 years. Okay, but when we are burning suppose 10 kg wood, that will generate instant pollution, instant CO2 in the environment. But for suppose it is 10 kg of wood generating, suppose 20 kg of CO2 maybe. So this CO2 will be maybe required. So a tree will grow and use the CO2 maybe in 5 years. So you can see the timeline. We have generated this much of CO2 in just 1 minute, but it's taking 5 years for the balance. Okay, so many things can happen to a tree as a part of natural process. So maybe you are planting a tree, so there can be many possibilities. So in this way, by considering a time scale, it is difficult to say that burning of biomass is clean. Okay, so we are also getting emission from burning wood like CO2, CO, sulfur oxides, nitrous oxides. Okay, we are also getting emission from coals, and you can see the calorific value of the wood is 15 megajoule per kg and the coal is 25 megajoule per kg. So you can see the difference. So wood is having less calorific value than coal. So if you want to replace 1 kg of coal, then maybe you will require 1.5 kg of wood. Okay, so you require more wood. So in this way, we are requiring more wood and we are generating the emissions. Okay, So the conclusion from this is that extracting energy from plant or plant-derived products is referred to a biomass energy. What is biomass energy? So the energy extracted from the plant or plant-derived products. Okay. Carbon neutrality of biomass may be more complicated to estimate than previously assumed. So carbon neutrality is quite complex, but the time scale is playing very important role in it. Okay. You have to see the time scale. Now the plant products can be directly used to fuel power plants or converted to petrol or diesel and then used. So these are three conclusions from this. Okay, now let's start with the questions. The first question is, OTEC principle is based on the space between the warm water at surface and colder water at approximately space distance below the surface. We are having four options. Take 2 minutes to answer.
Option B is correct.
Option B is temperature difference and 1.5 kilometer. Okay, let's wait for 1.5 minutes more. Anybody else want to answer? Please answer.
We can
Pressure
have D
gradient also. Pressure gradient also.
Pressure gradient. Okay, let's see. We will discuss. The question is the OTEC principle. So what is the basic principle we are using in ocean thermal energy conversion? What is the basic principle? The question is that. What is the basic principle is based on the warm water at surface and colder water at approximately, and we are asking, the question is asking the distance and what is the basic principle that is involved in OTEC. So one is saying pressure gradient.
No,
So
then
let me
principle
clear.
then no, it will not be. Only temperature part.
Yeah.
Difference.
Actually, pressure gradient is, yeah.
Pressure is not going to play any role.
Pressure gradient will
Although
not
pressure
play.
is there.
Yeah.
Pressure is although there, but it's not going to play any
Right.
part in the principle. Yeah.
Yeah. Actually, pressure gradient is not playing any part. Okay, in generation of the electricity. Okay, basically we are using the temperature difference. Okay, the major principle is temperature difference. Actually, pressure gradient is complicating the system. Okay, we have to design the system so that they can handle the pressure. We can design the equipment so they can handle the pressure. So pressure gradient is a negative part. If we look towards the ease of energy generation, so it is, you can say, hurdle, because as we have also covered that we have only gone up to 12 kilometer in the marina trench. Okay, so you can see, due to the pressure gradient, high pressure, as we go in the deeper in the ocean, higher the pressure, so it is very difficult to work there. So the major role is temperature difference. Okay, because the surface is at, you can say, 30 degree, and after 1 kilometer, maybe temperature is around 15 degree, 20 degree. There's a temperature difference of 15 to 20 degree. So we are using the temperature difference. We are using the temperature difference and up to 1.5 kilometer distance. Okay, so the correct option is option B. So the OTEC principle is based on the temperature difference between the warm water at surface and colder water at approximately 1.5 kilometer distance below the surface. So the correct answer is B. Is it clear? Any doubt? Okay, I think it's clear. Question number 2. If a person A and B are moving away from Earth's surface at a location on the sea, person A moving towards the Earth's center and person B away from it, then the pressure experienced will be. So we have given a situation. Please read it carefully. Based on that, answer. Take 2 minutes.
I think it is option A. It's always the same pressure, 1 atmosphere.
Exactly same for both. I just say please read question carefully. The question is if person A and B are moving away from Earth's surface at a location on the sea. So the point to stress out is person A is moving towards the Earth's center and B is away from it.
Okay.
So
Okay.
option
I
A is
changed.
not correct. Okay.
Not correct.
Yeah. So then the pressure experience will be. Read the question carefully.
Will be more for A than B.
Yeah. So as we know that person A is moving toward the Earth center. So as we go toward the Earth center, then pressure will increase. Okay. And B is moving away from it. So for B, so it will be more for A than B. So what are the correct options? Anyone want to answer?
Only one
C.
correct answer. C will be more for A.
So you are saying that correct option is option C, will be more for A than for B. Okay.
Yes.
So if you answer like this, then you will get 0.5 marks only, half marks only. Because I think you have not read the options carefully. Because it is not mentioned, as I have already told you in earlier classes, it is not mentioned
Yeah,
that only
will
one
be,
option is correct.
yeah,
B
will
and
be
C.
different.
B,
Will be
B and
different
C.
also.
Right.
Yes.
Yeah. Because if you are saying that
Not
will be
same
more
means
than A,
different.
it means that yeah,
Not
A
different
is not
means
equal to B. So option B. So option B is automatically correct.
This is
Okay.
not M.
If you
This
are
is
saying
MCA.
if
This is MCA or MSA.
the
yeah.
beauty of
So
logical questions.
yeah. So basically, if you are saying either C or D, then you have to also mark B. Okay. Because in both case, A and B are not equal. So A and B are not equal, it means they are different. So option B is only saying that thing. That that will be different. Okay. If you are marking option A exactly same, then you don't have to mark option B. Okay. So as I have already said, and today I am again saying that always go through the options. Okay. Just don't come under the impression that this option is correct. You know it confidently. Yeah, you know it, but always check other options also with some logics. Okay. Because maybe the same answer is in some just twisted. The text is twisted maybe, or same answer in some other option also. So try to look in that way only, so that you will get the full marks on the assignments. So the correct answers are will be different and will be more for A than for B. Number 3 is, what will be the approximately efficiency of OTEC plant if the surface temperature is 373 Kelvin and the colder water temperature is 298 Kelvin? So take 2 minutes and answer. You have to find out the approximate efficiency. You have given the temperature. So just assume the ideal conditions, because conditions are not given. You can assume the ideal best possible condition. Based on that, you can find the efficiency. So you have given the high temperature and low temperature both. Based on that, you have to find out the efficiency. So you can use the basic principle of thermodynamics. If you have given the higher and lower temperature in the using the ideal conditions, what can be the maximum efficiency with this temperature? Apply basic thermodynamics. You can think of Carnot efficiency maybe. Maybe that formula can be helpful for you. I'm giving you a hint. Just think about Carnot efficiency.
Option A, 20%, maybe.
Oh, maybe is coming, then I think you are not sure. Then you have to check other options also. So what is the formula for maximum efficiency? It is 1 minus TL upon T high. Okay. So try to use this formula and find the answer. So what are the conditions we are having? 1 minus, what is the TL? Is 298 and TH will be 373. If you solve it, you will get the answer. Anyone? What will be the answer?
17%. 16.8.
Are you sure? 1 minus 298 upon 373.
273. Okay, maybe.
I don't think so. Please recheck your calculation.
Oh, sorry. 1 minute.
So it will come around 0.2010. You can say 20% roughly. Okay. So
20%.
if you are having
That was
an
correct.
OTEC facility,
Yes.
yeah. So yeah, if you are having OTEC plant with the surface temperature 373 Kelvin and the cooler temperature 298 Kelvin, then the efficiency will be 20%. Correct answer is 20%. Question number 4. The general concept of a journey to the center of Earth is possible. This statement is. So I think you have all you have seen movie also. There is a movie, a very good movie, Journey to the Center of Earth. So is this concept possible? What are the answer? What is the answer? Maybe one option is true, maybe more than one option is true. So go through all options, take 2 minutes to answer.
It is false, sir.
Yeah, it is false. So we have to ask Steven
It is
Spielberg.
false. Okay. So yeah, correct. It is false because as we know that pressure and temperature both increase significantly. Okay, as you move from the surface towards the core of the Earth. Okay. So as of now, we have only gone up to 12 kilometers. Okay, because it's very difficult to go. So the correct option is option B, false, because pressure and temperature both increase significantly as we move from the surface towards the core of the Earth. Question number 5. Geothermal energy is tapped near the faults because their space easily accessible. So what is the answer? High temperature, high pressure, low temperature, low pressure.
High temperature.
Okay, high temperature. So anyone just tell me what is the basic principle of geothermal energy? What generally we use in geothermal energy? What is the basic principle? High temperature in the form of
Hot water or steam?
yeah. So high temperature in the form of, you can say, steam, hot water. Okay. So we are using that steam or that hot water by various means. We have covered 3 possible options for geothermal energy plants. One was dry steam, second was flash chamber, and third was binary. Okay. So by using these 3 systems, we can develop a geothermal energy power plant, and we can tap off the energy from these faults, okay, and to convert into electricity. So the correct option will be high temperature. Okay.
So this high
Question
pressure is
number
also
6.
there, as we saw in the last question. Last
High
question,
pressure,
question number 4.
high, yeah,
Question
high
4.
pressure is there. Yeah, high pressure is there when you are at that location. Okay, try to just to see it in that way. That this is the Earth surface. Okay.
Yeah, I know. I asked this question only. Yeah, right. Okay.
Yeah. So we are getting this steam at surface only. We are not installing the system at a depth, at some depth. Okay. At some depth, the water is there, but that water is coming out as a steam maybe. Okay. So that will coming out at only ambient pressure. Okay, because you are not running a system at this location at a depth. You are installing your system at a surface. Is it clear? Hello?
Yeah.
Yeah, okay. So pressure is not playing part. Pressure is playing part. Suppose if you are the faults are not there. Okay, once you have developed a fault, okay, or you have developed you have tapped a hole, then it's fine. From that area, you will install some pipes, and through those pipes, the steam will come out or hot water will come out. So pressure is not playing an important role. Just playing important role when you are digging that hole. Okay, but for energy conversion, we need high temperature. That is the main requirement. Okay, the question is that only. And that question number 4 was the journey to center of earth. It means that you are going towards the center of earth. The journey, you are going towards the center of earth. So basically you are not at the surface, you are going towards the center of earth. So pressure will play a role in it. The correct option is high temperature.
Okay.
Number 6, match the following. You are having water source and additional attachment or modification to the plant. A is hot water, superheated steam, saturated steam, in flash tank, directly run
Slide is
turbine or
not
binary
changed.
fluid cycle. Sorry,
Now it's okay.
are you able to see the question number 6?
Yeah.
Okay. So match the following. Okay, you are having a water source and additional attachment. What are the correct options, or maybe correct option only? Check and answer. Just take 2 minutes.
Sir, second option.
Option number second, A3,
Hot water to binary fluid.
B2. Okay.
Superheated will directly run the
Superheated
turbine.
directly run turbine and
Saturated to flashbang.
flash tank. Okay, let's see. Anybody else want to answer? One we have answer from one, that option B. Anybody else want to answer? Try to think our previous slides. We have covered these three in detail.
One question is this match the following also have multiple choice. So MSA, multiple select answer.
Maybe. I'm not saying
No.
it is
My God.
maybe.
Oh my.
Whenever no, actually, whenever you are doing any assignment or any question or any quiz, anything, Just read the question carefully. Is it mentioned that only one option is correct in question or not? Is it mentioned that only one option is correct? Yes or no?
No,
No.
nothing like
Yeah.
that.
So it is, yeah. So it is not mentioned that only one option is correct. So maybe I am not saying that every time more option will be correct. Maybe one or more option can be correct. So your responsibility is that go through all the options. Okay. Just don't directly the answer. Okay, B is correct. Okay, that forget all the options because you are just thinking that only B will be correct. No, it is not that case. Okay, maybe C is also correct. You have to eliminate the options just by checking that option that it is actually incorrect. Then only you can eliminate that option. So the concept is that only. That's why we are not mentioning that which option like one option is correct or more option is correct. Okay, so that student will think all the options. Okay, you have to check all the options, then only you have to eliminate the options, not directly by knowing the answer, because maybe we are just twisting the answer and putting some in other options also. Okay, let's come to the point. So what is the correct answer?
Second
one
and
student
fourth
is saying
likely to be.
Second is
Second
the
and
best.
fourth.
one is saying okay.
Second and fourth
So one
also.
is
Fourth also.
so two are saying second, and one is saying fourth also. 2 plus 4. Now let's see. So A3 hot water for the binaries hot water A3. Okay, if you are having hot water means you have to use the binary cycle or closed cycle because you will not get the steam enough steam. So by hot water we will use binary fluid and convert that fluid into steam and again condense, and we will run the turbine. So we are having high temp superheated steam, so we can directly run the turbine. Hello. Hello.
Yes. Go ahead.
Go ahead.
Yeah, are you able to see? Actually, I just got a pop-up that some issue is going on in MS Teams.
Yeah. Your voice was not coming for a little while.
Okay.
It was now it's okay. Now it is okay.
So option B is correct for sure. Okay, because we have covered all these topics. Okay, now let's see. One was saying that option D is also correct. So option D is saying A3. So A3 is correct. B1. So B1 means flash tank. Oh yeah, it's not correct actually. So I already told you that flash tank. So it is a tank that will reduce the pressure. By reducing the pressure, it means that it will convert more hot water into steam. More hot water to steam. Okay. So then we are using it. Okay. So if you are having superheated steam, so superheated steam means there is no water droplets. So why do you use the flash tank? Okay. So we don't require flash tank in case of superheated steam. Okay. Because superheated steam, it means that it is only having steam. There is no water droplets. Okay. So B1 will be incorrect. Then C2, saturated steam, directly in turbine, no. Because in case of saturation, there may be some water droplets also. Okay. So it cannot run turbine directly. We have
Yeah.
to use flash tank. So this flash tank will only give the steam. It
No,
will
what's
separate the
wrong
water
with
droplets.
running? No, what's wrong with
Yeah.
running a turbine with saturated steam? Only some corrosion will come. Otherwise, no issue. We can run. What's wrong?
So, so you think corrosion is a very simple thing?
Yeah,
Do you know
saturated
that? Do you
steam.
know
We can run. We
the
can
cost
run the
of?
turbine.
No.
Yeah.
Yeah. You can run the turbine. You are correct, but you are also saying that corrosion will be there.
Yeah, some problem will be there,
So
but we can run. No? Running is not the problem. Directly run the turbine. That option is correct. But
no.
Then
Actually,
maintenance cost will
running
go up.
means yeah. Because in practical you will don't use that, na. In practical you will not use that. Instead of hot water you can also run, because hot water will also have maybe some quantity of steam. Maybe you will just turn the turbine for 2 or 3 rotation. Okay. So it's not about the rotation. It's about the generation of electricity. Okay. And it's about the feasibility of the system. Okay. Because turbine blades are very costly. If there is corrosion, it means they will only for maybe 1 year, maybe 6 months. Okay. After that they will damage, and turbines are very costly. Okay. So whenever you are installing a turbine, then you are installing the turbine for around more than 20 years. Okay. Because only maybe after 10 or 15 years you will get your money back. Okay. There is payback period. I think if you have taken any course of techno-economics of any plant, maybe you know that whenever we are installing a system, then we are putting some cost for that system. Okay. There are various
ROI.
types of cost, fixed cost,
So
and
ROI.
different other cost
Yeah.
also. Okay.
That is called
Yeah,
ROI.
ROI. So yeah, it
Return
means
of investment.
always, no, ठीक है. Economics is another thing. It means technically any turbine is run on super saturated steam only, not with saturated steam in anywhere in the world or anywhere is not run like that. You want to say?
no, we don't. Yeah, right. We don't run. Yeah, we don't run on saturated steam. Yeah,
So
we don't
we
run.
have a
We
solution for
have to use
saturated.
the flash tank.
Yeah, we have
Yeah,
a
because
solution to handle saturated
we
steam.
can by just putting a but just putting a simple flash chamber. Suppose maybe that flash chamber will only cost you maybe 10,000 rupees or maybe 50,000 rupees. So by putting only 50,000 rupees, you can convert the saturated steam into superheated steam or pure steam without water droplets. Okay, then you can run the turbine.
Okay, please go ahead.
Okay, because just you are like not investing 50,000 rupees and you are damaging the blades of maybe 20 lakh rupees, then that is not economical. That is not maybe good option. Okay, let's put a flash tank that will remove the water droplets from the steam and will give pure steam. Okay, so basically flash tank is not converting steam to superheated steam. Okay, don't think in that way also. Flash tank eliminating the water droplets and increasing the quantity of steam. Okay, maybe that steam is also saturated, but X will be 1. The fraction of steam will be 1. There is no water droplets actually. So think in that way, that flash tank will remove any water droplets from the steam. The correct option is option A3B2C1. Question number 7. The use of biomass as fuel impacts food production. So go through the whole option, take 2 minutes. The use of biomass as fuel impacts food production. I think we have covered one area about the corn. Okay, corn or bagasse we have covered. So think from that perspective, and you can answer.
Sir, option 3 and 4.
Option number 3 and 4. Okay, false since the crops used are the same. False since the energy produced can produce even more food. Okay. Anyone else?
It's true. Since agriculture land is limited and if you are going for commercial stage production, there is a food shortages.
Okay, so now we are having some other options also. So maybe the previous student can rethink, or maybe you can rethink the recent answer. Try to come on a same answer. The question is the use of biomass as fuel. Is it impacting the food production? That is the question. That if you are using you are growing the biomass for fuel, like we have covered that some farmers are producing the corn for fuel for commercial purpose only, so that they can sell the corn to some industries, so that they can generate some biofuels. Okay, so maybe they are getting more revenues from that area, or maybe the maybe in sugarcane industry the sugar is just byproduct. The main product is bagasse. So that bagasse can be sold. Uh, that can be sold to the some industry to generate electricity or maybe generate power or fuel. Okay, so think in that perspective. From that perspective,
Ethanol. So
is it
sugar
impacting the food production?
sugarcane is having a very nice product bagasse, which is used for making ethanol, which is very helpful
Yeah, right.
for making
Yeah,
biofuel, biodiesel.
biodiesel, right.
So it is
So think
always
in
the
that perspective.
false community is more.
So what is your correct answer? What are you saying the correct answer will be? So what is the answer from your side?
C and D.
So I think two people are saying C and D. Okay, only one is saying A. Okay, so maybe those who were saying C and D, maybe you just didn't understand the question. What is the question actually? So try to rethink. The use of biomass as fuel impact food production. Try to rethink what is the question asking. Just don't go in broad way. Okay, it is clearly mentioned that the use of biomass as fuel. Suppose if you are using the biomass for biofuel production, then is it impacting the food production? Just suppose a case there are suppose 10 farmers. Okay, so those 10 farmers are giving the food supply to particular villages. Okay, so those villages are directly dependent on those farmers only. So some company came to those farmers, and the company told the farmers that we can buy your production directly. Okay, don't sell into the food market. We will give you more money. So those 10 farmers will supply the product, that their crop, to the industry directly. Okay, they will not go to market and sell the crop as a food grain. Okay, so what will happen? The villagers or the village, those were dependent on those farmers, they will have food shortage. Okay, because they were only dependent on those farmers. Okay, so think in that perspective. So final, anyone want to answer? I think one was answer A. Remaining two were answering C and D. Are you still on C and D, or have you changed your option?
Okay, I change it to A.
Okay.
As per your example, if it is really happening, then it is A.
Yeah. So anyone? I think one girl student is also there. Na?
Yes,
So
sir. A.
what is your answer?
Option
Still A. Okay. So yeah. So option A is correct, because just think about that, because we are having limited agriculture land. Okay. So the land is limited. Okay. So actually we have to find a balance. Okay. If every farmer will try to sell their crop for fuel production, then what about the food production? Okay. Because from the same land we are getting the crop. Okay. So as we are shifting toward the biomass energy production, then we also have to look in this perspective also. Okay. So it's very important, because agricultural land is limited. Question
Sir,
number 8.
one question.
Yeah.
One important point is food production is related to the crop which is grown by the farmers,
Yeah. Right.
and and the biomass is dependent on the material, the remains of the, like sugar cane, the remains of the sugar after taking the juice out of it. Bagasse you are talking about.
Okay.
Now the thing is,
Mm-hmm.
in this, why it was confusing, because food production is not going to impact biomass plants. I feel so. Food production
Actually, can you
is
think
coming
that
before the
no, no,
biomass condition.
no,
Now
let
just
me tell you. You are saying that bagasse, just take example. You are saying that bagasse can generate biofuels. Okay. After extracting the
making the
uh,
sugar.
juice. Okay. Making the sugar. Okay. Just suppose, just suppose that if you are directly giving the sugarcane to the industry, because just think about in that area that the waste, because if you think in your perspective, then if you are thinking from food production perspective, then your sugar is the main product. Okay. And the bagasse is a byproduct. Okay. And your bagasse is generating the biofuels. Okay. Just think that if you directly supply sugarcane to generate the biofuel, then will it generate or not? Maybe suppose the remaining of sugarcane is having such potential that they can generate biodiesel. If that juice were also present in the sugarcane, if we use directly sugarcane, then we can also do na. Actually, we will get more production. We are using bagasse because it's a food product. Okay. Similarly, if any, because we are using the bio waste, because that we cannot consume actually. Suppose the corn, suppose any agricultural residue we are using, because that residue is
This
not
this
useful for us.
this brings a question to the existence of biomass plant.
Sorry?
Existence of biomass plant.
No, it's not in such that way. Actually, if you search about this now, so in foreign countries, some farmers are only cultivating for the energy production. Okay. They are not selling their grains to the food production. Okay. They are generating, because the biomass, it is whenever you are putting the anaerobic condition, then anaerobic bacteria will not differentiate between that. I will only digest the residue. Okay. The anaerobic bacteria will not differentiate that I will only digest the residue. If you put complete food crop, complete agriculture crop in the anaerobic reactor, that bacteria will happily digest that food crop and will generate biogas, will generate different products. Okay. So actually it will
Okay,
easy
fine.
for bacteria to digest. Okay. So don't think in that perspective that only residue biomass means any biomaterial. Okay. It's not limited to the
Biodig.
residue. So yeah, any material that is biodegradable, which is biomass. Bacteria will don't differentiate between the agri residue or agriculture crop itself. Okay. Both are biodegradable. If you are directly supplying the agriculture crop, then it will bacteria will be happy actually. They will enjoy. Okay. So think in that perspective. So next question number 8 is a banyan tree lifetime is 300 years. If a fully grown banyan tree is burnt in thermal plant to generate energy, and a new tree is planted at the same time. So options are given. So take 2 minutes and give the answer. And one point is also that don't always think that maybe more than one options are correct. Okay, just go through the question and based on the question try to find the best possible answers. That is the main point.
There is option 2. Option 2 is only the one.
Option 2, the process will become carbon neutral only after many years. Yeah, it's the right answer, as we have already covered that. Because the maybe the complete banyan tree will generate electricity in maybe 1 minute or 5 minutes in power plant, but so if, the plant will generate so much of CO2 and other pollutants, but the tree we have planted at the same time. Okay, so the tree will grow, and after so many years only that will able to absorb that much amount of CO2. So the process will become carbon neutral only after many years. Okay. Option B is correct. Number 9, turbine blades are coated with space to increase space to reduce space of blades. So basically we are coating carbon turbine blades. Okay. Because if suppose there are still some water droplets, so they can damage the turbine by two ways.
It is ceramic to increase lifetime and reduce corrosion. The ceramic material to increase lifetime of the blade and to reduce the corrosion. Then option second is correct.
Okay, so reduce the corrosion. Option second is correct. Only second or any other option?
Fourth also, ceramic lifetime and abrasion also. Some
Okay.
metal
Yeah.
is not used.
Metal is not there, only ceramic to increase lifetime, and there is possibility of corrosion and abrasion. The correct answer are C and D. If the water boils at 100 degree at 1 atmosphere pressure, then at 2 atmosphere pressure its boiling point will be remaining unchanged, increase, decrease, it will be constant on earth. A very good question. It's about the boiling point. You can think of flash chamber or flash tank. I think in that I have covered this question.
Option 3.
Option number 3. Okay. Actually, read the question again. if the water boils at 100 degree at 1 atmospheric pressure, then at 2 atmospheric pressure, its boiling point will be. We are increasing the pressure.
It will increase.
Okay, yeah, right. If we
Same
increase
principle
the
applies. Yeah. Pressure
if we
cookers.
increase
Pressure
the
cooker.
yeah. If we increase the pressure, then the boiling point will increase. If we decrease the pressure, boiling point will decrease. Okay. So the correct answer is option number B. Let's have a quiz. Use of biomass represents the capture and release of the same amount of carbon and hence is considered safe for the environment. True, false?
True.
True, right? Because as of now we are taking it as a carbon neutral, but just the time span part is actually tricky. But we are considering it as a carbon neutral. Temperature deep inside the ocean is relatively unchanged by the time of the day. True or false?
It's also true.
Yeah, because up to a certain depth only the solar radiation is affecting the temperature. Beyond that, the temperature remains unchanged. True. The composition of the Earth can be determined in part from information on how earthquake waves travel through the Earth. True or false? I think we
It's
have
also
covered
true.
4 different ways by which we can determine the composition. Yeah, so it's true.
True.
4. Cool water from deep inside the ocean can be directly used for air conditioning.
Yes, that's true.
In the OTEC, yeah, it's true because we can directly use the cold water in air conditioning. Okay. OTEC based system are low in efficiency but can be evidently tapped.
Yes, true. Statement is true.
Statement is true.
True.
Yeah, because we are having so much of water. Okay, so we can evidently availability of this system. Only the part is that efficiency is low. So maybe in future with different systems we can increase the efficiency also, and we will look into the system that can be installed easily. Okay, so I think it's enough for today. So NPTEL team will provide you the recording of this doubt class or this live session, and this PPT will also provided you by the NPTEL team, so you can refer this PPT and video recording. Okay, I hope this session was good for you.
Yes, very good.
Okay.
Very interactive.
Excellent.
Okay,
Sir,
thank
one
you.
request. One
Yeah,
request
please.
is that we would like more of these MCQs, MCS, MCQs questions. Because, it is quite
Okay.
tricky sometimes, and it gives a complete 360-degree jolt to the brains. When some questions like
Yeah, right. Actually, we are also
can you
having
give us
some
some
time.
option where I can get more questions on these, like these individual topics of OTAC or biomass or any other?
Okay.
More of these questions.
Okay, I will try to find some sources, and next time I will share those links with the PPT.
And put it
So
on the
because in the
announcement.
class, the time is yeah.
Yeah.
Because the time is limited, so I cannot discuss more than 10 to 15 questions in the class. Okay, so maybe I will put the link in my PPTs. So using those links, you can access those questions. Maybe I will find some
Yeah.
sources, and either you
That-
can also search on the internet maybe, because yeah.
The internet is a vast ocean, sir. I would prefer NPTEL team to give
Yeah.
us some old last year question paper or something.
Okay. Actually, I will ask the NPTEL team regarding this also. Okay. Sure.
Yeah, that will be grateful. Thank you so much.
Sure. Okay. Thank you so much for attending, and I hope everyone will also come on next Monday, time 6 to 8. Okay. Thank you.
Thank you. Okay. Thank you.
Thank you.